Everyone wants more from their Mazda. More power, better sound, improved performance, and the aftermarket industry is happy to sell you exactly that. Cold air intakes, tune files, exhaust upgrades, coilovers, bigger turbos. The forums are full of enthusiasts who swear by these modifications. Best thing I ever did to my car. Huge power gains. Transforms the driving experience. But here's what those same forums don't tell you as loudly. The threads where the engine failed at 70,000 miles. The posts where the turbo destroyed itself after a Stage 2 tune. The stories of cracked pistons, spun bearings, and destroyed cylinder walls. Those stories are there. You just have to know where to look. I've been working on Mazdas for years, and I've seen the aftermath of these modifications firsthand. Customers come in with modified Mazdas expecting me to be impressed. Sometimes I am, but sometimes I'm looking at an engine that's been quietly destroying itself since the day the mod was installed. Today I'm exposing the common Mazda modifications that are destroying engines, why they cause damage, and what you should do instead if you want better performance without sacrificing reliability. This isn't anti-modification content. I love a well-built performance car, but I hate watching good Mazda engines die from preventable mistakes. Let's get into it. Mod number 1. Cheap cold air. Intakes. Cold air intakes are one of the most popular and most misunderstood Mazda modifications. The theory is solid. Cooler, denser air creates a better air-fuel mixture, which improves power and efficiency. Quality cold air intakes from reputable brands deliver on that promise. The problem is the cheap ones, and the market is flooded with cheap ones. They destroy your MAF sensor. The mass airflow sensor measures the amount of air entering the engine, so the ECU can calculate the correct fuel mixture. Cheap intakes don't seal properly. They have micro gaps that allow unmetered air into the system. The ECU doesn't know about this extra air. It calculates the fuel mixture based on what the MAF reports. Result? A lean fuel mixture. Not enough fuel for the actual amount of air. Over time, lean mixtures cause overheating, detonation, and piston damage. They introduce dirt and debris. Cheap aftermarket filters have inferior filtration media. They let through particles the factory filter would catch. Those particles enter your combustion chamber and act like sandpaper on cylinder walls, piston rings, and valves. What to do instead? Use a quality drop-in high-flow filter from K&N that fits directly in the factory airbox. If you want a full intake, use reputable brands like Mishimoto or Ingen, and always pair with a proper ECU tune on turbocharged models. Mod number 2. Aggressive tune files without supporting modifications. This is the most dangerous modification category of all. A tune modifies your engine's ECU parameters, ignition timing, fuel delivery, boost pressure, everything that controls how your engine operates. Done properly on a built engine with supporting modifications, a tune dramatically improves performance. Done improperly, it destroys engines fast. Here's what I see constantly. Someone downloads a Stage 2 tune promising 50 extra horsepower. They install it on a completely stock engine with 70,000 miles. No upgraded intercooler. No upgraded fueling. No upgraded cooling. The tune pushes more boost than the factory hardware was designed to handle. Intake temperatures spike. Detonation occurs. Connecting rod bearings start wearing. 3 months later, the engine throws a rod. $7,000 engine replacement for a tune that cost $400. What to do instead? Build up supporting modifications first. Upgraded intercooler, high-flow injectors, upgraded fuel pump if needed. Use a reputable tuner who knows Mazda platforms specifically. Get the car tuned on a dyno, not with an off-the-shelf file written for someone else's car. Never tune a high-mileage engine without first doing a compression test and leak-down test. Mod number 3. Incorrectly installed oil catch cans. Here's a modification that's actually beneficial when done correctly, but damaging when done wrong. An oil catch can intercept crankcase vapors before they enter the intake. Since Skyactiv engines use direct injection and can't wash intake valves with fuel, reducing oil vapors that cause carbon buildup is genuinely valuable. So what's the problem? Installation errors destroy engine seals. The crankcase ventilation system maintains specific pressures to keep seals and gaskets functioning correctly. Install a catch can incorrectly, and you create blockages or restrictions that build crankcase pressure. That pressure pushes oil past seals, causing leaks from the valve cover, oil pan, or rear main seal. Cheap catch cans that don't work. Budget units have poor separation efficiency. Oil mist passes straight through and enters the intake anyway. You've added a potential failure point while solving nothing, forgetting to empty it. A catch can fill up. If you forget to empty it, oil flows directly into the intake. You've just sent raw oil into your combustion chamber. What to do instead? Buy a quality unit from Mishimoto or Radium Engineering. Have it installed by someone familiar with Mazda's crankcase ventilation system. Check and empty it every single oil change without fail. If you're enjoying this video, give it a thumbs up and subscribe to my channel. This helps me bring you more honest car advice for my Mazda guys. Mod number 4. Wrong spark plugs. Here's a modification that sounds logical, but causes real problems. Upgraded spark plugs for Mazda engines are a popular modification. Higher heat range plugs, iridium tip upgrades, racing plugs. In Mazda Skyactiv engines, these are almost always damaging. Why factory plugs are already optimal? Mazda spent thousands of hours testing spark plug specifications for the Skyactiv engine. The heat range, electrode design, gap, and material are precisely matched to the combustion chamber geometry and compression ratio. A plug that's too cold doesn't burn off deposits. Carbon fouling follows. A plug that's too hot causes pre-ignition and detonation. Piston damage follows. The gap matters enormously. Many aftermarket plugs come pre-gapped for different applications. Installing a plug with the wrong gap causes misfires, rough running, and increased fuel consumption. Over time, misfires cause catalytic converter damage costing $1,200 to $2,000. What to do instead? Use OEM Mazda spark plugs or the exact equivalent from NGK or Denso, matching the factory specification. Pull the factory plug number from your current plugs. Match it exactly. Don't upgrade. Don't guess. Mod number 5. Cheap coilover suspensions. Coilovers replace factory struts and springs with adjustable units, allowing you to lower the car and tune suspension stiffness. Quality coilovers from KW, Teen, or BC Racing are legitimate upgrades. Cheap coilovers, suspension destruction in a box. What cheap coilovers do to your Mazda? They force your suspension geometry outside its design parameters. Your control arms, ball joints, wheel bearings, and CV axles were engineered to operate within a specific range of motion. Drop the car too low with cheap coilovers, and every bump puts those components under stress they were never designed to handle. Wheel bearings fail at 30,000 miles instead of 100,000. CV axles crack from operating at extreme angles. Ball joints wear out in half their normal lifespan. The tire and alignment nightmare. Improper suspension geometry causes extreme uneven tire wear. You'll replace tires every 15,000 miles instead of 50,000. And cheap coilovers often can't be properly aligned within factory tolerances, meaning you spend hundreds on alignments that can never fully correct the geometry. What to do instead? If you want to lower your Mazda, use quality lowering springs, $200 to $400, paired with upgraded struts designed to work with them. If you want adjustable coilovers, budget properly. Expect $800 to $1,500 for quality units. Don't cheap out on something that directly controls how your car handles emergency maneuvers. Before we continue, if you want the complete guide to maintaining your Mazda and protecting it from damage, whether stock or modified, Click the link in the description to download your 500,000-mile car maintenance blueprint. It covers every service interval, modification guidance, and everything you need to protect your Mazda for the long haul. Let's keep going. Mod number 6. Exhaust headers without proper heat management. Aftermarket exhaust headers improve exhaust flow and can genuinely increase power on Mazda engines. But improperly installed headers without proper heat shielding cause serious problems. The heat problem: headers run extremely hot, much hotter than the factory exhaust manifold. That heat radiates into the engine bay, cooking nearby components. I've seen rubber coolant hoses melt from improperly shielded headers. Wiring harnesses fry, causing electrical gremlins that take days to diagnose. Brake line degradation from heat that led to brake failure. The oxygen sensor problem. Headers change exhaust velocity and temperature at oxygen sensor locations. This throws off fuel trim calculations, causing the engine to run lean or rich. Without a tune to compensate, you have check engine lights, a fuel economy hit, and engine damage risk. What to do instead? Budget for quality headers with integrated heat shielding. Install heat wrap on sections near sensitive components. Always pair with a proper tune. Have it professionally installed by someone who understands Mazda-specific fitment. Mod number 7. Stretched tires. Here's a modification that's popular in the car show scene, but genuinely dangerous and destructive. Stretched tires involve mounting a tire that's too narrow for the wheel, creating a distinctive angled sidewall look. In car shows, it looks aggressive. On the road, it's destruction. What stretched tires do to your Mazda? The tire's contact patch is severely compromised. Handling, braking, and cornering are all significantly degraded. In emergency maneuvers, stretched tires can roll off the rim completely. The compromised geometry puts massive stress on wheel bearings, which fail prematurely. I've seen Mazdas with stretched tires destroy wheel bearings in 15,000 miles. That's $400 to $600 per bearing, and there are 4 of them. Up to $2,400 in premature wheel bearing replacements. Plus, your insurance may void coverage in an accident if stretched tires contributed to the cause. What to do instead? Use the correct tire size for your wheel diameter. A staggered fitment, slightly wider rear tires than front, gives an aggressive look without destroying your suspension. Mod number 8. High-stall torque converters on street cars. Here's one specific to automatic transmission Mazdas that almost nobody talks about. A high-stall torque converter allows the engine to rev higher before the transmission engages fully. In a race car, this improves drag strip launches. On a street-driven Mazda, it's transmission destruction. Why it destroys transmissions? A high-stall converter slips more than the factory unit at lower speeds. All that slipping generates heat, massive transmission-killing heat. Mazda's factory cooling system is designed for the factory converter's heat output. Add a high-stall converter and you're generating heat the system can't handle. Transmission fluid degrades rapidly. Clutch packs overheat and fail. I've seen automatic transmissions with high-stall converters fail in as little as 20,000 miles on otherwise well-maintained cars. A new transmission costs $6,000 to $10,000. What to do instead? If you want better transmission performance on the street, focus on fluid quality and proper service intervals. Leave the high-stall converters to dedicated track cars. The modification mindset that protects your Mazda. I'm not against modifications. Done right, they genuinely improve your driving experience. But there's a right way and a wrong way. The right way: research thoroughly, use quality parts from reputable brands, pair modifications logically, tune when needed, and maintain more frequently because modified engines work harder. The wrong way: buy whatever's cheapest on Amazon, install it based on a YouTube video, ignore warning signs, and blame the car when it fails. Every modification in this video is destroying engines not because modification is inherently bad, but because they're being done cheaply. incorrectly or without the supporting hardware they require. Your Mazda is a precision machine. It responds well to quality upgrades done properly. It responds poorly to cheap shortcuts. Know the difference. Spend the money to do it right, or leave the car stock and spend that money on maintenance that makes it last 400,000 miles. Both are valid choices. And if you want the complete maintenance guide that protects your engine, whether you're running stock or modified, don't forget to grab your 500,000-mile car maintenance blueprint from the link in the description. The bottom line: cheap cold air intakes introduce unmetered air and dirt into your engine. Aggressive tunes on stock hardware, crack pistons and spin bearings, incorrectly installed catch cans, blow seals, and push oil into your intake. Wrong spark plugs cause misfires and destroy catalytic converters. Cheap coilovers destroy wheel bearings, CV axles, and ball joints. Unshielded headers melt wiring and cause brake line failure. Stretched tires destroy wheel bearings and compromise safety. High stall torque converters cook automatic transmissions in 20,000 miles. Every single one of these problems is completely avoidable. Use quality parts. Do your research. Support your modifications properly. A stock Mazda that lasts 400,000 miles is worth infinitely more than a modified Mazda that dies at 80,000. If you found these tips helpful, be sure to watch this next video as we're sharing insider tips to help you cut repair costs and keep your car running like new.